Database indexing isn't some deep magic ritual, and you definitely don't need a PhD to get it. Honestly, if you've ever used a book's index to find a specific chapter, instead of flipping through every single page, you already understand the core concept. Imagine you're at a massive library looking for a book about space. Without an index, you'd have to walk down every single aisle, tilting your head to read every spine until you find it. In database terms, that's a full table scan. It's slow, it's tedious, and it's a total waste of your time. Now, if that library has a catalog at the front, an index, it tells you exactly where space is. You go straight to the S section, find the shelf number, and walk right to it. That's all a database index is, a separate map that tells the system exactly where the data lives so it can skip the manual search. Most databases use something called a B tree. Think of it like a perfectly organized family tree. Because the index is sorted, the database can use a binary search, cutting the data in half, then half again, over and over, until it lands on the right record. This is why your queries stay fast even when your tables get huge. You might also run into hash indexes. These are like direct shortcuts. They map a value straight to a location. They're incredibly fast, but they only work for exact matches. If you're looking for a range of dates, they won't help you. But here's the catch. Indexes aren't free. Every time you add, update, or delete a row, the database has to update the index too. If you have too many, your writes will start to crawl. Also, indexing something with low variety, like a true or false flag, is usually a waste of space. There aren't enough unique values for the index to actually narrow things down. Then there are compound indexes. Let's say you're always searching by both name and age. You can index them together. But be careful, order matters. The index helps if you search for both or just the name. But if you search for age alone, that index is basically invisible to the database. You have a table with 10 million rows, you add an index for every single column because you think more is better. Now your inserts are dragging, your disk space is exploding, and you're wondering why everything is broken. The fix is simple. Only index what you actually query. Think of it like a shortcut. Without them, you're checking every row. With them, you're jumping straight to the finish line. It isn't always a scaling problem. Usually, it's just an organization problem. Know your query patterns, use your indexes wisely, and your database will thank you. Consider subscribing if you like this.